Hello everyone, my name is Bhavna Polireddy and this is my final project for CSEI 549 Automata Theory for summer 2025. So in this video, I'll walk you through my CKY passing project. I'll cover the domain and I'll cover the grammar which I used and I'll cover the rules which I used for parsing and also how I use the CKY algorithm to parse the natural language queries from the domain. So these are all the table of contents I have, like project domain, a list of, I have like 15 list of valid sentences and 3 list of invalid sentences. And also I have context-free grammar, which I defined for the sentences. And also I have CNF form, how I converted, and also I have the CKY tables. Here I'm going to explain about my domain. So I chose the computer science domain. The domain I selected for the project is computer science, specifically focusing on the technical queries and the questions that students or learners might ask in areas like data structures, machine learning, and Python programming. The sentences reflect real world queries like, can you explain the model? What is the sorting algorithms? And the goal was to build a grammar that can phrase such domain specific queries accurately. So these are all the sentences that I have used, and I have like a list of 15 sentences. So these are all the list of 15 sentences I have used. These are all 15 sentences are valid, and I have used like 3 invalid sentences as per the professor rules. So the sentences I used, for example, the sentences I used for the valid cases are, can you explain any clustering? Shall I get any model complexity? Shall I get any textbook? Can you recommend a Java textbook, etc.? These are all like, I have like still 15 sentences, which I'm going to explain how I converted, how I proved them as valid and how I proved the invalid sentences as invalid. And for converting a CFG to CNF, so we have like a few steps which we need to follow. The first step is eliminating null productions, and the second one is elimination of unit productions, and third step is conversion of CFG grammar to CNF form, and the step 4 is construction of CKY tables. These are the four steps that I'm going to follow for uh, for constructing the CKY tables for the CFG grammar, which I need to convert from CFG to CNF. So for CNF conversion, we have to follow 3 steps, which is eliminating null productions, removing unit productions, breaking longer rules into binary productions. Um, so I have used context-free grammar. So if you see my context-free grammar, I have explained like these S implies NP and VP, S implies auxiliary NP and verb, phrase, noun, phrases, pronoun and proper noun and determinal nominal. So these are all the rules that I have designed for the each and every phrases. So I have So if you see the noun phrase, I have chosen the model, complexity, clustering, textbook, classification, and data structures, both based on the knowledge. So nouns can be model, complexity, clustering, textbook, classification, etc. And the pronouns can be I, it, me, you, she, her, what, or which. And I still have a few nouns, so I have like divided them. So now let's see how we convert CFG to CNF. The grammar in which each production having one terminal or max of 2 non-terminals in the right side of each production is called CNF. So we should have one terminal or max of 2 non-terminals on the right hand side. Uh, so that condition, if that condition satisfies, then we can call it as CNF. So let's now look at the valid sentences from the project. So I applied a CKY algorithm for each and every sentence. For example, in the sentence For example, in the sentence, uh, let's take, can you explain any clustering? So this sentence, we need to break down this sentence into different parts. So can be auxiliary based on the rules that we have, and you can pronoun, you can be a noun phrase. Explain can be a verb. Explain can be a verb phrase. Any should be a adjacent, and clustering is nominal, and nominal noun NP. So if you see the first row in the table, which will explain about the rules that we have, and the second row, which will explain about the relationship between sorry, the first column explains about the relation between each and every individual word. So it will explain about the relation between can you explain any clustering, and the second line in the box shows the relation between the current and the previous word relation. So if you compare any and clustering, and if you check the relation between any and clustering based on the rules that we have, any is an adjacent and the clustering is a noun and the nominal. So let's see how we have this. So let's see how we have adjacent nominal. So if you see adjacent nominal, so we have the So we have the relation between these two as NP. So we have NP here. So let's go and compare the explain and you. So if you go and compare the explain and you, the you is a pronoun or noun phrase, explain is a verb and the verb phrase. So if we compare the relation between both of them based on the rules that we have, it says S comma B. And if we see the relation between S and B, it's S. And if you see the relation if you see the relation between S and VP, we have we will get SB based on the rules that we have that we provided, and the relation between S and B, if we compare the S and B, we will get an S. So if we get an S at the end of the comparisons or end of the relation, the sentence is like a valid sentence. When the sentence is run through the CKY parsing table, each word gets a terminal tag in the bottom row through the recursive filling in the table using the CNF rules. The topmost cell contains, sorry, the bottom of the cell contains S. This confirms the sentence is valid, and this is successfully passed by the grammar. So how we can confirm the sentence is valid is, if we get S at the end of the table, or at the top of the table. I have written at the end of the table, but few people can write at the top of the table. So this can confirm the statements are like valid. And also we have a few other examples. So I have like 15 examples for the valid sentences, which I can explain, or which we can go through. If you see all the sentences, I got it as like as at the end of the table, which means those are all valid based on the rules. And also I have written everything with hand, and then I have attached the snippets for the tables. So if you see the invalid sentences, I have like three examples for the invalid sentences, which is the first one is algorithms, which for sorting. So if you see at the first glance, it seems to be related to the domain, but grammatically it doesn't follow any valid rule structure. So algorithms is a noun, NP, noun phrase, nominal, which is a pronoun or question of the word, and for is a preposition, and sorting is a noun again. It's a nominal as well. There is no production rule in the grammar that allows which to follow algorithms directly, or a structure like noun, pronoun, preposition, noun, which passed like when we pass when we pass this sentence using the CKY table, we see that although individual words are recognized, the parser cannot build up to the start symbol S. If you see the relation between the noun sorting and for noun and the preposition, the relationship between the noun and preposition is PP, and the relationship between the pronoun and the noun, we don't have any relation between them based on the rules that we have. So the bottom cell of the table is empty, indicating that the sentence is not derivable by the grammar and therefore it's invalid. If you see the last table, last row in the table which is empty, which states that the sentence is not able to derivable by the grammar and therefore it's an invalid sentence. So I have other few sentences. If you see machine learning, any explain. Machine learning is a noun, any is an adjecent, and explain is a verb. If you see, we don't have any relation between uh, any of these terms, which is verb, adjacent, noun, based on the rules that we have. And also, if you see the third example, explain classification that model. So if you see the explain is a verb, classification is noun, that is determ, and the model is noun. So if you see if you check the comparison between noun and determine, it's an NP, and we don't have any relation between we cannot derive S at the end of the table. So this is not a valid sentence. So which we can through this we can say that we can prove the sentences are valid or invalid based on the rules that we provided. So in the summary, we can say that this project, like I can say, like this project helped me to deeply understand how CFGs and parsing algorithms work, especially in the context free grammar or context of natural language processing. I gained hands-on experience in designing grammars, designing CKY tables, and designing the rules, designing the terms how it can be, and covering them and converting them into CNF and applying CKY passing algorithm for synthetic analysis. So this is my final project. Thanks for watching the video.